Okay, let's go ahead and get started. Our question of the day last time was about vaccination. I was surprised the percentage was that high. That's kind of interesting. Percentage of people being vaccinated. I guess maybe I was surprised that this was this low. I might have thought that there would be more people who were thinking that they wouldn't get vaccinated. Anyway, that was interesting. I didn't mention that there's a link here where you can suggest a question of the day. I am doing what I did in 142 last quarter. If we end up choosing one of your questions, then you'll get a 1/3 of a homework point. Tiny little incentive, tiny little bonus to encourage you guys to suggest questions of the day so we can get some interesting questions. We have a TA who picks them. So if you're interested, you can click here and suggest a question of the day. The homework has been posted. I mentioned last time that if you go to the Zoom links tab, that you will see TA office hours. There are TA office hours today, over the weekend, next week. So if there's anything that you need help with, any questions about style issues or any of the material that we're covering, understanding arrays, understanding classes, go to the TA office hours to get some help. One of the things that is true that I wanted to mention, I handed out homework 1 on Wednesday, which means that as of Wednesday, you had seen everything in lecture that you needed to see in order to do the homework. So today, I'm going to be covering material that won't be part of homework 1. This would be material to use in future homeworks. So that's always the way that I do things, is that the day that a homework goes out, that's kind of the material that you need. So there wouldn't be stuff that we would cover later. All right, so today we're going to be kind of switching gears a little bit. We've been looking at ArrayList and trying to understand its implementation. Today we're going to be looking at being a client of the built-in ArrayList and a built-in structure known as a set. So that's what we're going to be talking about today. There was one thing I meant to do last time that I didn't get around to doing. I wanted to show you a quote from a fellow named Joshua Bloch. So Joshua Bloch is a Java guru. He wrote this book called Effective Java that many people consider to be a very important book. Joshua Bloch was the architect of the Java collections classes. So the things like ArrayList, that we're using are things that Joshua Bloch was in charge of, the group that put that all together. Under the links tab, I have a link to this book if you're interested. He has structured the book as a series of 90 tips. And if you click on this, the table of contents for the book are the tips. So if you're interested, you can see his 90 tips. You can see read what the different tips are, because that's how the book is structured. They are the individual sections of the book. So you can read the 90 tips. If you want to read what they're about, you have to buy the book. So, but that's an interesting resource if you're interested. I'm going to show you 2 Joshua Bloch quotes today. So the first one I meant to show you last time, but I forgot to do it. So we talked about encapsulation, about the idea of making fields private and so forth. And I wanted to kind of bring Bloch in as a witness to convince you that this is important. He says the single most important factor that distinguishes a well-designed component from a poorly designed one is the degree to which the component hides its internal data and other implementation details from other components. A well-designed component hides all its implementation details, cleanly separating its API. API is short for Applications Programming Interface. So assuming you were going to create an application, you were going to be programming an application, and you wanted to know how to interface, how to be a client of one of these things, like an ArrayList, for example. The ArrayList API is the description of how you, as an application programmer, can interface with the ArrayList, how to be a client of the ArrayList. Anyway, cleanly separating its API from its implementation. These are the 2 views. Components then communicate only through their APIs and are oblivious to each other's inner workings. This concept, known as information hiding or encapsulation, is a fundamental tenet of software design. So I basically am just quoting him to let you know that, the fact that we think this is really important is not just us. Joshua Block thinks it's really important. All right, I'm going to bring up a Java program that's, we saw basically this program on Monday. I was showing you this as a way to talk about ArrayList to motivate as we moved into looking at ArrayIntList. And I mentioned that I had some comments in there that kind of talk about the translation of, if you know array style coding, how to do ArrayList style coding. So we know that arrays, you can have, various kinds of elements in array, an int bracket bracket, a double bracket bracket, a string bracket bracket. You can have all sorts of different kinds of elements with a bracket bracket after it. Well, for an array list, you put that type inside of the less than greater than. Array list of string would be the equivalent. So down here, I've kind of done that. Array list of string list is a new array list of string. I mentioned something that I've kind of done this the tedious way on purpose so that I can kind of talk about it. Whatever you put here inside the less than greater than would also have to appear here. And Java has they decided after a while, why make programmers do that? If we want this to match that, why don't we just allow you to leave it off on the right-hand side and have a less than greater than? The less than greater than is the diamond operator, is kind of the name of that. And so a later release of Java made it possible for you to leave that off. We didn't use that in the first 4 editions of our textbook, but starting in the 5th edition, we changed everything to use the diamond operator. You don't have to use the diamond operator if you don't want to. It's up to you, but it's simpler, and it reduces the probability of making mistakes. But it's on the right-hand side, not on the left-hand side. So when you're describing a type, you do need to use the string. But over here on the right-hand side, when we go to construct something, Java infers the type. It sees that the variable here is of type ArrayList of string, so it knows to put the of string inside the less than greater than. So then this little notation says, instead of saying new string of 10, you'd make a new array list using the diamond operator. There's various translations. You ask for the length of an array, but you ask for the size of an array list. Length does not use parens, size does use parens. You may remember that string has a method called length that uses parens, 3 different conventions in Java. Why are there 3 different conventions? Because Java is stupid, because the people who designed it sometimes do stupid things. There's no good reason for why this is so. It just is. It's something we have to live with. And what do you know about size for array list? You know it's a method because it uses parentheses. This does not use parentheses, so we know that it's a field. The interesting thing about this being a field, you'd think you could say then array.length equals 17, and kind of change the length of the array, but this is a final field, so it's not allowed to be changed. But anyway, with arrays, you don't use the parens and you call it length. With array list, we call it size, and we do use the parens. There's a get method that's like the bracket notation. If you wanted to assign a value at a specific index, you do have remove and add, so you could remove the value there and then add something back in. But if you have a really large list, that's very wasteful. Like if there's 10,000 elements and you want to change what's at the front, you don't want to have to shift down 9,999 of them with a call on remove and then shift them all back again to do an add. So list.set is useful to change the value at a specific index. It does not change the structure. It doesn't add anything to the structure or remove anything from the structure. It just changes the value at a specific spot. And then there are the extra methods. We've been talking about these: removing at an index, adding the appending add that adds at the end, adding at an index, and a clear. We'll talk about the set operations later in the lecture. So anyway, a little review here if you're interested. I wanted to talk about a specific idea. Let me use a text window for this. I wanted to talk about an example of what we would call abstraction. There are a lot of people who say that abstraction is at the core of computer science. It's one of the most fundamental things about computer science. So what is abstraction? What I would say is that this is separating the essential properties of something from the unimportant, I'll scooch over, important details. So there's kind of low-level details that we ignore when we're doing abstraction. Kind of it's this separation into what's the high-level essential aspect versus the low-level details. The reason that we do that is because programming involves so many details. You know, your head explodes after a while because you can't deal with it all. I have a quote in the textbook from Brian Kernighan, and I looked it up. I was just kind of curious to see whether there's very much on the web, and there's tons on the web about this quote. Controlling complexity is the essence of computer programming. It's a quote from Brian Kernighan. There's a picture of Brian. He was a professor at Princeton. Interesting guy. I've had a great conversation with him when I visited Princeton. Apparently a lot of people think this is a good quote because they've made little images of it and even t-shirts and so forth. So, I mean, this is a way of saying that abstraction is important. You know, controlling complexity, because that's the main tool we use for controlling complexity, is to do abstraction. So we're going to see an example of this starting today in the form of something that's known as an interface. So what are interfaces in Java? An interface is basically a list of behaviors. And we'll do a programming example in a second, but let me just kind of briefly mention, I mentioned the Arthur Riehl idea of a radio, and how many of us know how to use a radio, how many of us know how to build a radio. Those are the kind of the two different views. Well, if you wanted to think about, and I used it also to talk about the idea of state and behaviors. What are different states a radio could be in? What are different behaviors? Well, so what if you wanted to think about radio behaviors, which is basically our interface with a radio? You know, kind of what would be the things that you would expect to be able to do? So if I put, you know, I mean, I could put all sorts of things in front of you. I could put a box of cereal in front of you and say that this is a radio. I think you'd look at it and, this isn't a radio, you know. So what do you have to have in order to qualify to be a radio? Well, there's a lot of things, but in particular, what I wanted to be thinking about would be what would be your expectations of user controls? Kind of what is your interaction with this radio? And it's great when I have an audience to be able to answer this, because people are pretty good at coming up with answers to this. One of them is that it would have an on-off switch. I mean, if you don't want it on all the time. It would be annoying if the radio was on all the time. And so this is something that we expect to see. A box of cereal doesn't have an on-off switch, so it's, you know, that's one reason why it's not a radio. But so we would expect that this would be one of the controls that's available to us that allows us to interact with this radio, an on-off switch. What else? And I asked the class for suggestions, and people say, you know, change the station, you know, the frequency. If you're always tuned to one radio station, that's not a very useful radio. So we'd expect, I don't know, a dial or something that allows us to change the station to something different. Change the volume would be something that we would expect to be able to do. Sometimes you want it loud, sometimes you want it not so loud. There are other behaviors of a radio that I'm not talking about here because they aren't our interaction. It's kind of like the radio should do certain things. Like when we turn it on, we expect that it makes some sound, you know, and as we change the station and change the volume, we would expect that it's producing sound as we tune it to a specific station or something like that. So those would be things that we would expect to have available to us in interacting with the radio. There's a couple more that people sometimes think about, sometimes not. You know, you want to be able to see the channel, you know, so there's usually some kind of a display or something that shows you that you're tuned to 93.5 or something like that. And now that I mentioned 93.5, it reminds me that AM/FM is usually another thing that we kind of expect. As most radios, you can switch between AM stations and FM stations. But being able to see what the channel is, see the volume setting, these would be things that we would expect to have available to us for a radio. Well, what we've described here is something, this is a non-programming example, but it's a lot like what a Java interface would be. We would basically be saying that if you want to claim to be a radio, then you have to have the ability for us to interact with you in this way, that these different behaviors are things that we would expect you to have. Now, when we do it in the Java way, we're going to be more specific, and we're going to say actual names of methods and parameters and return types and so forth. Well, let me show you such a thing. So, or maybe I'll back up a little bit and just mention something else slightly different first, which is that ArrayList is a specific structure in Java that allows you to store lists of things. It's a very specific kind of structure that has an array inside, and we've been looking at its implementation details because we've been creating our own variation of it known as the array int list. But there are other ways of storing lists. The week after next, we're going to be talking about something known as a linked list that doesn't use an array, it uses a different strategy for storing things. So there are different ways to implement a list. Let me show you, there's something in Java which is a list interface. Notice it doesn't say array list, it says list of E. And this is an interface in Java. So an interface is a kind of an abstraction. It's trying to describe the essential properties of a list. So I'm basically saying the essential things are that it has an appending add, that it has add at an index, it has a clear method, an index of method, a get, a remove, a set, a size, add all, contains remove, remove all, something called iterator that we're going to talk about in a minute. So these are all things that I would expect. It's like the list I was forming over here of the things that I would expect of a radio. If you want to claim to be a list, I would expect that you would have all of these methods. And so there's a way of doing that in Java by defining an interface. We're talking about the idea of interfaces today. We're going to see how to actually define an interface next week. So we'll see a little more detail about how it's done. But for now, kind of the way of thinking of it is that it's a way of separating off this list of behaviors from the underlying implementation. So the interface doesn't say whether there's an array that's used to store it, a linked list that's used to store it, whatever, that could be stored in all sorts of different ways where there are very different low-level implementation details. This is our API, our application programming interface, that these are just kind of the commands we'd give to a list if we wanted to manipulate it. Some of you are going to kind of say, well, yeah, but what's the bottom line? How is this important? How are we going to apply this? Well, let me tell you the bottom line. I've been saying to you that you might want to write down things when I tell you about these are style issues that we grade on. So let me tell you about a particular style issue that we're going to be grading on, which is that we want you to use interfaces when it's appropriate. So here I'm declaring a variable, and I've declared it to be of type ArrayList. So that means I'm saying that it can only refer to an array list. And actually, when we declare a variable, it's preferable to use the interface type. So I'm going to declare that to be of type list of string, using the interface, rather than using the specific ArrayList type. On the right-hand side, when I go to construct it, I do have to use the specific type. Because you're constructing an actual object, you have to tell Java what kind of object it's going to be. So when you're calling new, you will use the actual name of the class. You'll use ArrayList. But in all of these other cases, you're going to be using the interface type. So you'll use it for variable declarations, you'll use it for parameter types, you'll use it for return values from a method, and you'll use it for fields. So all of those things should be declared using interface types. If you're interested, I've mentioned, so on our links page, there's this Java API documentation. So you can look this stuff up yourself if you're interested. I remember when I first looked at this, I mean, there's different reactions you can have to something like this. Look at how many classes in the Java class libraries start with the letter A. I mean, this is ridiculous how much stuff there is here. I mean, does anybody know even a small percentage of all of this stuff? So I just laugh. It's crazy how vast Java is, how many of these things are available. H, I, J, K. All right, we're finally to the point where I can find list. So I'm going to click on list, and it says here, interface list of E. An ordered collection, also known as a sequence. The user of this interface has precise control over where in the list each element is inserted. The user can access elements by their integer index, position in the list, and search for elements in the list. So the kind of general description here, it mentions, by the way, known implementing classes. It mentions ArrayList, and it mentions linked list. So those are two. There's others too, but those are two of the known ones. And if you scroll down, you'll find things like there's the appending add, there's add all that we talked about, and there's a lot of other stuff, contains, but we didn't talk about contains all, for example. So there's even more stuff here than what we talk about. So if you're interested, you can read the internal Java documentation. This version of it that I showed you here, these are kind of the core ones that we'd want you to know about, the ones that we'd want you to use on an exam. This will be in a cheat sheet that we give you. Well, it's not a cheat sheet, but it's in a section handout that we'll give you next Tuesday. You'll see this list. It'll be available to you. It'll be in the notes for today's lecture as well, if you're interested. This is the second time that I want to bring Joshua Block into this and use him as an expert witness. His item 64 is refer to objects by their interfaces. You should favor the use of interfaces over classes to refer to objects. If appropriate interface types exist, then, and this is the same four things I mentioned, parameters, return values, variables, and fields, those four things should all be declared using interface types. The only time you really need to refer to an object's class is when you're creating it with a constructor, when you're calling new. So he's just saying the same thing that I had said. And so the style issue is that if you weren't using list of string, you weren't using the interface when you can, you'd lose a style point for that. And that'll be true starting with homework 2 moving forward, is that we'll expect you to use appropriate interface types when they exist. Let me spend just a couple of minutes saying a little bit about why do we do this. I can tell you, a lot of novices find this very confusing. They're kind of like, why wouldn't you just make it a type array list? Why would you want to have the more generic type? And so I guess, one of the things that I'd say as a motivation, I give the example, I say, suppose that there's somebody on campus, I usually ask people for the name of dorms they live in, like some students tell me they live in a dorm called Elm. So suppose there's somebody in Elm who makes cookies, really great cookies, and is selling them, starting a business. And they wanted to describe what type of customer they deal with. Well, and if this is all within that one dorm, they might say something like Elm resident, are there customers? But then, what happens when somebody from Poplar apparently is the dorm that's next to Elm? What if someone from Poplar kind of comes over and sneaks into the dorm and says, I want to buy a cookie? Can I buy a cookie? Well, maybe Elm resident then is too specific. So maybe what we'll say is something like UW student, would be what kind of customer type you would have. What if I show up? I'm very interested in cookies. I make cookies myself. Are you going to say you won't sell cookies to me? Okay, maybe we'll make a UW person, so that we'll allow anybody who's associated with UW to show up, buy cookies. And then let's say that that our mayor hears about, your great cookie business and shows up, are you going to say that she can't buy cookies? So maybe we'll say something like Seattle person, then Jay Inslee shows up. Well, okay, maybe a Washington person, and then Joe Biden shows up. Okay, American, we'll send it to South India American. Well, what about somebody visiting from France shows up, or Boris Johnson from, the UK shows up? Okay, human, and then the Klingons show up. Okay, humanoid, we'll sell it to anyone who's a human. And then Commander Data shows up, who's an android, will you not sell cookies to an android? So I think that really the kind of thing you would want to do is to describe a very generic kind of customer, something like something that can pay. You don't care whether it's Klingon, human, android, whatever. Anything that shows up and can pay money can buy cookies from my business. So that's kind of an example of where we would want to be as general as possible, because that makes the business more flexible. We can have a larger customer base. And in a similar way, when we declare this variable to be of type list of string, it could refer to an array list, or it could refer to a linked list. It's more flexible. When I wrote my critter code that many of you will have used in the 142 class, I used the less specific critter name, even though you have specific kinds of critters like lions and bears and huskies and so forth. The critter code is written in the more generic form so that any critter, can participate. So anyway, that's a short little example of why you might want to have something that's less specific. We looked at this code on Monday, so I'm not going to do a lot with it, but let me just kind of do a quick compile and debug. Let's just review. We'll watch this executing. So we go ahead and construct our list. I can drag this out, and I can change kind of where it appears on the screen, and the size and so forth. So, and remember that there are different kinds of viewers when you're working with a list. It's nice to use the presentation viewer. This is meant to be an indication of an empty list. So, and then it does the adds, right? 4 score, 7 years. So it add, it adds these different things to it. There's other controls that are here where I can change the width of what it's showing for these things. I can change the size of these things. So I've got 4 score, 7, then it's kind of executing a little more. Years, what was next? Ago, so I set up this screwy version. Then I added at index 2 the word and, so it goes ahead and does that and scooches the other things over. It removes at index 5 to get rid of that text that I didn't really mean to have. It goes to do a println command. You may remember that when we did this kind of thing with an array, it gave us a weird output, which was not very helpful. We had to call arrays.toString in order to format it properly. Not so with array lists. Array lists have a toString that does a nice format, and so there's the nice format that we're getting from it. It's asking where is there a 7 in here, and it's at index 3, so it finds that and prints that out, and then it prints a blank line. So that's just kind of, we already talked about those various commands. That's a little bit of review. I want to use this example to talk about a few more things, so I can end our debugging session. I wanted to talk about the idea of a traversal, because it turns out there's several ways to traverse a structure, like a list structure, like the array list. So there's a standard traversal that we do for int I equals 0, I less than, and if this were an array, remember we'd say list.length is what we say in the standard array traversal. In the standard array list traversal that's described in chapter 10, we say list.size with the parens, because that's the replacement for length, I++. And in the standard traversal, we do something with an array, you do something with list bracket I. In the case of a list, you do something with list.get of I. So we use the get command the way we would use square brackets with an array. This is just kind of a standard traversal that prints out the different values from the array, one per line. And we'll do a little blank line because we're going to do other printing, and we'll separate this from the other stuff that we do. So that should be very familiar, standard ArrayList traversal. If we compile and execute, it's just printing out one per line, 7 years ago. So that's the standard traversal. There's a variation that I want you to know about known as the for each loop. We have Microsoft to thank for the for each loop. I mentioned this in my 142 class, but I'll just kind of repeat it a little bit here for those who haven't heard me talk about this, that in the 90s, when Java was first becoming popular, Microsoft started using it. And then they did something that's a very Microsoft-like thing to do, which is they started making libraries of code for Microsoft only. And the people at Sun Microsystems who controlled Java got very angry and sued them, and there was a huge fight. And Microsoft kind of decided they needed their own thing, so they created something called C#. I would have described it as their alternative to Java, but with all the lawsuits going on, they didn't want to describe it that way. They said that it came from C++. And it does have some things in common with C++. But, so I've always thought this was an interesting question. Is it really more like C++ or is it really more like Java? They said it's, it all comes from C++, believe us, because they didn't want to help with the lawsuits. I'm serious that there were people at Microsoft who told me at the time they're not allowed to use the J word, Java. The lawyers have told us not to use the J word. I made the joke in my 142 class last quarter that it would be great to have Maury Povich, who does these paternity tests. These dramatic shows where he'll bring out a mother and her baby. So I kind of imagine Microsoft with her baby C#, and here's C++ sitting next to Microsoft, and when Microsoft says, "Well, this is the father of my baby." And then they bring Java out, and everyone's like, whoa, that baby sure looks a lot like that guy, and they do a paternity test and figure out who's the real father of this. I'll give you an example. In C#, there is a class that's known as ArrayList, but you wouldn't say ArrayList of string in C#, you would say ArrayList of string with a lowercase s. And for that array list in C#, you wouldn't say list.add a string like hello. You say list.add with a capital A. Very different than Java. Maybe not. Anyway, I hope I don't get involved in a lawsuit. I think the lawsuits are long gone, so I think we don't have to worry about that so much anymore. But in any event, in C#, C# was meant to be a competitor to Java, and so they introduced their own stuff, and they included something known as a for each loop with a special keyword for each, where you did, you kind of did what I'm about to show you. Java wanted to have something similar, but maybe they were a little nervous about making it look too much like C#, so they didn't use the word for each, they used the word for. But here, otherwise the syntax is the same, that I can say something like the following. For all of the strings, I need to have a name of a variable here. I can use any variable name I want. Sometimes I use a simple variable name like s when it's a string, but it could have been, text or whatever. Any variable name would do. But I say for all of the strings s that are in this list, I want to do a system.out.println of s. So this is a much simpler syntax than the standard traversal syntax. Here I had to have an index variable, comparing against size, calling get. Here I just say, hey, for all the strings that are in there, print them out. So it's much simpler syntax, the for each loop syntax. Java calls this the enhanced for loop. I think that's something that the lawyers came up with. No one calls it the enhanced for loop. In fact, if you make a syntax error, the compiler tells you that you have an error in your for each loop. So everyone knows this is the for each loop. But in any event, this is another way of doing it. It's described in Chapter 7 for arrays and Chapter 10 for ArrayLists, and so it's perfectly fair game. I'd encourage you to use it. We have sometimes graded on this, you know, to make you use it when it's appropriate. So there was that first bit of output from the standard traversal. Here's the second bit of output from the for each loop. We're not going to grade on this, you know, because there's just so many other things we grade on. This doesn't seem that important. But, you know, I'd recommend that you use it, you know, when appropriate. The when appropriate part has to do with whether you're changing the list. So this is a read-only operation. So for each loop is a good thing to use when you're reading a structure. It doesn't work when you're changing the structure. All right, I want to tell you about a third way of doing this so that we know all of the different variations of this. This is going to be a little less compelling with lists. You'll see that it makes more sense when we do the sets in a little bit. We're going to talk about that as well. But there's something that's known as an iterator. So an iterator is a kind of object in Java, and an iterator has three different methods to it. A method called hasNext. Is there any more data? You know, it's basically a method that lets you know whether there's any more data. A method called next. This returns the next value and moves forward. So in some implementations of an iterator, these are separate operations. We're kind of looking at the next value and moving to the next value are separate, but not in Java. In Java, it's one thing. Next returns that thing to you and has moved forward, has moved the iterator forward. And then there's a method called remove, removes the value most recently returned by next. So basically, with an iterator, you can ask for the next value, and if you see something about that value that makes you think you don't want it in the structure, you can ask the iterator to remove that value from the structure. So there's kind of this option to remove things as you're looking at them. There's some limitations on that. So for example, if you call next and then you called remove, you couldn't call remove again because you're not allowed to remove two backwards. You're only allowed to remove the most recent one. So that would be an error to kind of call remove two times in a row. We'll talk about that a little more in Monday's lecture. So iterator. And there is an interface for iterators as well. So I'm going to have an iterator of integer called ITR. Before we do this, let me. All right. I'll go ahead and do this. Iterator of integer ITR, and you might have noticed this when I showed you the various list methods that something is assumed to have. There's a method called iterator. So the way that you set up an iterator is that you ask the structure that you're working with to make an iterator object for you. So here I'm asking the list to create an iterator for me. So it does the call on new. It constructs the iterator. Now, you wrote code like this using scanners, so you're probably familiar. We tend to write a while loop while the iterator has a next value to be processed. Depending upon what we're going to do, we might want to do something like string next is iter.next. We might want to store that in a variable. And then I could say something like system.out.println, that next value. In this case, if that's really all that I was going to do, then I don't really need this variable. I could have just had the call on iter.next inside the parens. That would have been perfectly fine. But often you want to do more than one thing, so it's not so bad to show you this version of it where we're tucking it away in a variable. So this is kind of another way of doing it, is ask the structure to give you an iterator, and then you use the iterator to go through, next, 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 to get the various values. So this should give us, what did I do? Iterator of integer list dot iterator. So my list is an array list. Oh. What was I thinking, iterator? I need people in the room to kind of tell me, what am I thinking about? These are strings. Why would I say integer? Okay, I was confused. But maybe I was doing it on purpose to see if you guys were paying attention. But all right, yeah, string. What was I thinking? Who knows? So now I have 3 bits of output. Okay, so we've seen this 3 different times. All right, that's one bit of stuff that I wanted to show you. I wanted to show you, kind of switch gears a little bit and talk to you about this other structure known as a set. But let me first say a little bit about, I was kind of thinking that this was coming up next. I'm sure this is why I had this in mind. That how would we store, so suppose we wanted to put these different values into an array list. So if I wanted to have an array list that was going to store these different values, you might imagine that I'd have an array list of int. I'm going to call it numbers1, is a new array list. We can use the diamond operator. So you might imagine you'd put int here, and then you could say things like numbers1.add an 18, numbers1.add 72. You could compute a product as numbers1.get of 0 times numbers1.get of 1. So you might do something like this to kind of fill it up with a couple of values that you then multiply together. So that kind of makes sense, and that's actually what you do in C#, is that you would have an array list of int. But in Java, they didn't do it that way. They decided that for array lists, you have to have an object type there. So they introduced what are known as the wrapper classes, nothing to do with lyrics for songs, different kind of wrapper, wrapping up a primitive value. You know, the analogy that I've used is that it's kind of the way that caramels are gooey, and you know, if you had a caramel on your hand, it might get all sticky and everything. So you put it inside a wrapper. You know, the idea is that int is not easy to work with, so we have something called integer. That is the name of a class that has integer objects have exactly one field of type int. They wrap up an int into an object. So in Java, we would say integer instead. There's other wrapper classes, you know, for the type Boolean, there's a Boolean with a capital B. For type double, there's a double with a capital D. Those are the wrapper types, the wrapper classes. And now this wouldn't work anymore, right? Because I'm doing an int when it's expecting an integer. And in the original version of Java, this code didn't work. I had to do special stuff to kind of make this code work. But again, that competition with Microsoft made it easier to do stuff like this. So they changed it in Java. You can read about it in chapter 10 if you're interested. That Java will kind of say, well, look, that's an int. And I understand the relationship between an int and an integer, so I'll wrap up that int for you, something known as autoboxing, and I'll turn it into an integer, so I'll allow you to do that. And here, it looks like you're multiplying 2 things together, and you can't multiply 2 integer objects. Oh, but I understand that, you know, integers have ints inside, and so it will automatically unbox for you. So actually, this code works in Java to do something like this. Because of that competition with Microsoft, they changed Java so that it does this auto-boxing and auto-unboxing. So as far as you're concerned, you can kind of think of it as if it's an array list of int, even though it isn't really. We say integer, but we think of it as being an array list of int. Any issues that you see here? Remember what we said about style, that you should use interfaces whenever possible. That's not an interface. I'd be losing a style point if I wrote it this way. We better fix that and make that a list of integer. I'm going to do a little for each loop over the array. You can do for each loops over an array as well. For all of the integers n that are in that array called data, I'm going to say numbers1.add n to the structure. And then I'm going to say system.out.println numbers1 is equal to numbers1. So nothing terribly exciting, adding things in order into an array list, and then we see our sequence of numbers there. But I wanted to do this as a way to be able to talk to you about this other structure known as a set. And there's an interface type for sets as well. I'm going to call this numbers2. On the right-hand side, though, I can't use the interface type. I have to tell it a specific kind of set. We're going to use something known as a tree set. So that's the kind of the specific type. And for set, there's a list of operations as well. I included several of them at the top here in the little comments that I mentioned, that there's an add and a remove. Remove now, though, doesn't remove at an index. It removes a specific value. And you can see if it contains something, if it has a size. This list here for set had some extra things in it as well, including an iterator. This, again, will be in the notes for today, and it'll be in a section handout that we make available to you on Tuesday. So add command contains command. If I wanted to do something over here, so while I'm adding things to my list, let me go ahead and say numbers2.addN. So I'll add it to the set as well. System.out.println numbers2 is equal to numbers2. Numbers2. Let me make a copy of that because we're going to do a few of those things. So I ask you normally the class, what's the difference between a set and a list? And there's math people who will say that sets are unordered. And that's kind of the right thing. So maybe describe it slightly differently. With a set, you don't get to pick the order. So it picks the order. For a tree set, for example, the tree set likes to keep things in sorted order. So you may not want it in sorted order, but tough luck. You know, the set decides what the order is. You don't get to decide the order. If you want to decide the order, you should have been using a list. So sets are unordered in that sense that you don't get to pick the order, and they don't have duplicates. So they kind of eliminate duplicates. So let's see what happens when we add the same set of numbers to these two different structures. So that was the sequence, you know, that you see in the list. In the set, there's a lot fewer of them because it's gotten rid of duplicates, and they're in increasing numerical order. So as I mentioned, if you wanted to remove something, you'd have to say something like numbers2.remove and not give it an index because it doesn't have indexes. You give it a specific value. Like what if we wanted to remove the 42? And then we could print it afterwards. Then you tell it the 42, you know, what's the value that you want it to remove. So if we compiled and ran that version of it, we can see, you know, it gets rid of the 42, you know. So that's how you remove something directly from a set. Well, what if you wanted to remove, say, all the multiples of 3 from a set? How do you traverse through a set? It has a for each loop, the way that a list does. But remember, for each loop is a read-only operation. So it doesn't have anything like the standard traversal. It doesn't have indexing. So how are we going to go through it? This is a case where we really need an iterator. So I'm going to say that I want an iterator of integer. This is where I want iterator of integer, itr2. So I'm going to ask numbers2 to give me an iterator that'll iterate over it. And then I can say, while iter2 has a next value, I can say int n is iter2.next. I can kind of get the next n. And what would tell me that I want to get rid of it? Multiples of 3. That's what I said. We wanted to get rid of multiples of 3. I usually tell my class that Stuart loves mod, so this is a nice application of the mod operator. If n mod 3 is 0, how do we remove from a set? Well, we could say to numbers2, I want you to remove that n. So we could do that, and then we could print out what we get afterwards. So this should remove all the multiples of 3. If we compile and run, it compiled properly and ran, but then it did something called, it threw a concurrent modification exception. So it turns out that this is a bad way of removing from a set. That if you're iterating over a structure, the iterator does not want you to change the underlying structure. So that's what we'd be doing by talking to the numbers2 set. If we're talking to the set and telling it to remove something, the iterator notices that the set has a new structure to it, and it threw the exception. So if you're going to do this, so this is, you practice this in section next week. If you want to remove from a set, you have to have the iterator do the remove. So because the iterator gets mad if you're also talking to the set. So we don't want to talk to two different objects. We let the iterator do the work. So if I compile and run this version of it, I end up having eliminated the multiples of 3. I probably want to say a little more about an iterator, but I think we're about to be cut off, so I'm not going to have quite the time to do it. Maybe I'll mention that mod count that we saw is used for this concurrent modification exception. That the iterator notices if someone else is modifying the structure, that's how it knows to throw the concurrent